Hey everyone, it's me again, and I'm continue doing this open source project that is supposed to merge Half-Life maps together into one giant mesh. This is a C reimplementation of the old version that I had like 5 years ago or something. And I was doing this is a second episode, and in the first episode I was doing the code overview, and I didn't finish it last time. I think I will be continuing this today. Hi to everyone in the chat. Привет, Павел Судаков. Привет, Jeffrey. This stream is mainly in English, but I will switch sometimes to Russian to answer questions. Стрим в основном на английском будет идти, но я могу по-русски отвечать на вопросы. So let's continue. So last time I showed you all the main parts of this thing, and what's left were, I think, so there was Atlas. I think I briefly told you about how it works, about the API, but how it works. Okay, maybe I don't remember exactly how it works, but it was the Atlas generator is used to have one. So main use of this code is to be able to generate one single texture, single light map texture for the entire level, because in BSP format, in BSP files, the surface light maps are stored in weirdly sized small chunks, which can be 2 by 2 pixels or something, or some weird stuff like 7 by 23 pixels or something like that. And I merge all those small pieces together into one giant texture that is bound to known, designated texture OpenGL texture unit, and I don't switch it. Currently I'm rendering only single level, and this texture doesn't get rebound. Like this texture unit is pretty much constant. So, and the idea here was it doesn't do anything fancy. It's basic, a very basic algorithm that you can probably find on the first Google page, like how do I write Atlas, texture Atlas, and so it doesn't do any doesn't store any history. It doesn't look back. It just it's being fed rectangles one by one, and it tries to put them into the best spot there. I can probably look at what I got here. I will now try to write with with a pencil, just and not with the mouse. This will look horrible for first. I think I'm not used to tablets, so this will look bad but I think with experience I will get better. So the Atlas algorithm idea is really simple. Is something like so we get a rectangle. Okay, this is bad. Anyway, and we go with we get a small piece of some picture that we need to fill here, and what it does, it just okay, it doesn't actually matter from what corner I start. Like OpenGL stuff starts from this one, like in math, because this is a 0 point and this is like 1 0. Okay, this actually looks bad. Okay, this 0 1. and this is 1, 1. But it doesn't actually matter. So for this one, we have Кринтию привет. It's what it does have, this algorithm, it stores a list of free regions within this texture, and it starts with a region that is like the entire texture, and it gets next rectangle, it tries to fit it within any free region. We have only one, so it picks this region and inserts it at this position. And then it splits the remaining area into 2 free regions. So basically this is now not free entirely, and it has some like depending on the width, I think it depends on like left width, whether this height is bigger than this width, but I don't remember exact details. So let's suppose it splits into this bigger area and smaller area. So now it has 2 free areas in the list of free areas, this one and this one, and it gets another picture, and it tries to fit it within any of those free areas, and it tries to find the best match, like whether it will fit the free region more closely. Like let's, for example, like get the next patch will be like a bit smaller, so this one will be the best match because it will free this small area here, it will leave this large free area intact, and it will next split, like it's obvious here that it will have this free area, really small one, which probably won't get used for anything, like unless we do get like something small like that in the future. So we end up with 3 free areas, like this one, and this one, and it goes goes forever. Like for all the incoming pictures, it tries to fit them, and this is really, really simple. And surprisingly, this algorithm works really good. Like it doesn't leave any apparent like large free spaces that can be occupied by anything, and it would probably be possible to optimize to get better results with like doing back propagation, like doing history, like okay, let's start with another, like let's sort our incoming pictures and like try to fit them. But even this isn't actually needed for anything, it just works like that really good for the data that I have in BSP files. So one thing that I do have iterations for is I start, maybe you remember this, but so what, anyway, BSP, I have a chat message, ничего страшного, привыкнешь к планшету, я тоже криво рисовал. Я попробую порисовать прямые линии, но пока, в общем, не нужно было. Ну, то есть кривые коробочки нормально для передачи того, что я хочу сказать. So, let's go to the BSP-C file and find atlas. And what it does here, it tries to calculate the minimum possible atlas size. And then it just iterates until it can actually fit all the light map patches into this atlas texture. Yeah, basically the atlas compute function may return the insufficient temp memory, or like it couldn't do anything. I actually interested, like there were, I think there are 3 errors. Yeah, the success that it was able to fit anything. It couldn't fit any all the rectangles, and it ran out of temp memory, because like it does have the it does use the temporary memory for free regions. It stores the like array of free regions. And it's actually interesting, like it's obvious that we actually do know the size of maximum possible size of free regions, like maximum possible count of free regions, if we know count of rectangles that we must fit within this Atlas texture. Like, yeah, max rex count, it was just 1 plus the rex count. Yeah. And yeah, this is the Atlas texture generator. And another thing that I didn't get to explain in last time is the collection interface, which is used for reading resources from like collections. Collection currently supports only file system as a collection, but I do have plans for being able to read VPK files natively, because as you probably remember, I use VPK Fuse for mounting VPK files as just part of file system, because I'm working on Linux and it's possible to do that. This is why basically this utility won't work out of the box on Linux or on Windows, because the file system stuff is pretty much Linux only at this point. I will fix that in the future, but not right now. So there's pretty simple interface for a collection, which is like close when we need to close a connection. I don't think that it actually used by anything, because we do open like stuff, read it, and stick with it forever. And it can open a named resource. So we've passed a collection interface, whatever that is, resource name, resource type, which can be map, material, texture, and model. Models aren't supported currently. I don't do anything with models. And it returns its result with this. This is ifile, which is basically a thing you can read and close. You can read like, I want to read size bytes from offset into the buffer, and if you don't need the file anymore, you can close it. So there anything like cursor or anything, it's just some buffer that you can read. Yeah, and collections may form a list, and then you can chain open the collection, so it will try every collection in the list until it finds one that does give you the needed result. This is used because this is actually close to what Source Engine does, I believe, because they have like this list of VPK files, and some files are actually like on the plain file system, and it tries every like resource collection in some order that is specified somewhere to read the needed file. So it's, for example, it's possible like just to add some file or like VPK file to override the existing resource. And another thing that let me open it. BSP file for format. Okay. This thing, there was some lump pack file lump, I believe. Yeah, this is a lump that might contain other files that are needed for the level to load. I believe it contains a lot of textures that I'm missing right now. This is another thing that I will be doing. Like, I want to be able to load those. Currently, I'm not. I don't do any tricks about it either. Okay, and this is internal implementation of file system collection. I don't do any dynamic allocations here, so it basically has a predetermined amount of open files that can be opened simultaneously, and it works fine. So have path, and yeah, it's pretty simple. Yeah, this is header basically. Yeah, it also has file size, obviously. This is this header, and this is some internal file stuff, and this is flag whether it's opened. This is interesting. So there's this thing, file map, which is, I believe, a memory mapped file. Okay. File map C. Yeah, this is a memory mapped file. Linux specific, obviously. Like, not Linux, but POSIX, I think. Or... okay. File map open, file map close. Okay, so I do have like a memory mapped file here, but I don't actually use it. I use like the simple, straightforward file API, which is Linux specific. Let me check. Period. I think this was... no, it's also POSIX stuff. Okay, this period function is cursor-less function to read from file, like to read from some file offset. And yeah, this is basic stuff. Okay, next thing that I had here. There were... okay, the collection implementation is really straightforward. Like, just depending on the file resource type, it concatenates strings to find the directory and file extension. Трансляция приостановлена. I think I have okay, there's some issue with YouTube, streaming on YouTube for some reason. Okay. I have no idea what's going on there. Okay, let me reload this. YouTube. Arch 1 бальт, привет. Okay, let me check other streams. Like, so, Goodbean doesn't like my high H264 profile for some reason, and Twitch is happy. Twitch is happy, and yeah, everything else is fine. Anyway, this thing, this is a bunch of pretty, not like ugly C code, like stream manipulation, stuff like this. Nothing to see here actually, like just concatenate all the strings to get the file name and then try to open it from the file system and return if it was successful. And yeah. Список используемых технологий и программ. Можно конкретнее. То есть редактор Vim с какими-то плагинчиками там. Что еще? На Linux с этим OS'ом, этим, как он называется, Window менеджером. Ателофан, привет. So, yeah, this is like not interesting. Explore and material is a material structure. Cache, yeah, this is basically resource cache. I didn't couldn't come up with any like good how do I say it, like abstractions, I guess, API for it. So it's just get material from cache, put material to cache, like get texture, put texture, and really straightforward stuff. This cache is implemented as, yeah, this is also really simple. Like there's custom made like hash, which is a hash, a header only thing for storing hashable. I forgot the name of this data structure. Язык программирования C, библиотек никаких библиотек не использую, ну, кроме системных, понятно, там. Я даже libc стараюсь не использовать. Хотя в основном приходится. Компилятор, да, все равно, что Clang, что GCC, то есть там. So, basically, anyway, as I forgot the name of this thing, basically it's data structure that you, an associative array, dictionary or something like that. So you can insert an object, a named object, like string to some key value, like string to some stuff. So basically you textures are inserted into this hash, into this structure by name, and you can get them by name. And this kind of functionality can be implemented in many different ways. Like it can be from a simple array, like even non-sorted array that you iterate through every time you need something from it, to like sorted array where you sort by key, to like some trees, red-black trees, or like something even more complicated. Many ways to do this. And this stuff is just, as I know, not know, but I estimate the size of the count of objects that will be in this structure, around like a couple of thousands, I guess. So I do this thing. I divide the entire dataset into some buckets, and each bucket is... Oh, let me remember what I do. I actually forgot what I'm doing here. So the number of buckets, key size, value size, allocation function, key hash function, key compare function. So there are item size, value set. Okay, this is technical stuff, and pointer to buckets array. And each bucket is, this is internal stuff. Each bucket is just a pointer to items and count of those items. So basically the bucket is chosen by the hash. So we calculate hash. There's a key, hash function which calculates a hash number from the key data, which is this way the hash number determines the bucket number, and then for each when we get the bucket, we simply go through the items to find the exact match. If we need to insert, or if we need to read, like get an item or insert one. I think this is over-engineered a bit for the data I have here. D3PL, thanks for follow. Подсказать курсы или книгу для изучения шейдеров. К сожалению, никакой конкретной хорошей штуки не могу подсказать. Сказать. Могу разве что подсказать вот такой сайтик, постоянно его рекомендую, но он не по шейдерам, а просто вообще. Ну, естественно, шейдер той, то есть шариться на шейдер той очень полезно. Вот. Ух ты. I haven't seen those ones. Okay, this is cool. Anyway. So this thing is over-engineered, and I don't actually remember what happens when a bucket needs to grow. Okay, this is yet again a really dense and ugly C code here. Like new item, I need to allocate new item, so it copies item into its storage. Okay. And then yeah, it copies all. Yeah, I don't think that this stuff is like, I don't like it. Just something that I came up with quickly to get to get things done. I will think about this, what I want to do with this. So cache collection hash bsp common dxt is the dxt unpacking, which is buggy. I will need to look at it. libc, it's a collection of libc stuff that I use. Material is a simple subset of the materials that I use to render. Like, Source Engine has a lot of materials. Okay, maybe I should go to like this and try to materials. So yeah, it has. Do they have a list of materials created? No. So basically there are a lot of materials. Each materials defines properties that can be set. Properties can like be textures or numbers or stuff like this, or like whatever. So this is generic, light map generic. So yeah, there may be several textures and some parameters. And I support only really basic stuff like 2 textures. I bump detail. No, I don't do those. Actually, I don't do this. I think I do only 1 base texture, but I really wanted to do some complicated stuff here at some point. Like, not complicated, but yeah, more interesting, I guess. And no. src material C. So this thing. Okay, this is a parser of some kind. So material get. So basically, material get is used to get a named material from a collection using stack for temp memory storage. Okay. So first it tries to get a material from cache. Okay. And if it wasn't able to get material from cache, it lost one from collection. And if it can find one from collection, it basically material is defined by some text file. And then we try to parse this file here, which is like some callback based parser. Yeah. Okay, so I just have some temp memory for the entire material text. And yeah, I read it, and then I expect some tokens. Okay, so this is really another ugly C part, like parser in C, which parses this file format here. Won't go into details because I don't remember them. Parser context. Yeah, this is crap. Okay, so at some point I do get like next string parameter name and beautiful parts. Like there are some like structure parts that I consider like acceptable. Like the BSP parsing part that doesn't use any allocations, I think is pretty cool. like it does allocate some temp memory, but it's like it's stack based, so it allocates some chunk of stack and then frees it by just moving pointer back to where it was, and this is cool. But yeah, there are some ugly parts there too, like I'm not happy with the displacement part because it's not right. There are some glitches with it that I was unable to fix. And to properly reverse engineer the displacement, it's like a lot of work, and I just don't want to go there. So this one reads key value pairs, and this one, like there, yeah, this is the loop, and at this point I just compare the key, and when I find something that I actually know how to work with, I use it for, yeah. So I read textures, detail text. For some reason I believe I don't use it. So I do read a lot of textures, but yeah, let me check. Render, SRC render. I believe I'm not using those textures. Yeah, I use only texture 0 and light map. Okay. Basically I think I just didn't have enough time to like write a couple of GLSL lines to support more interesting thing. Anyway, so this is material. And yeah, this just fills this structure with pointers to valid textures. Next thing is textures. A texture is it is just directly a render texture with this, which is an OpenGL resource and some metadata like width and height. And this is like texture C, VTF format, Valve texture, something. There are a lot of textures, a lot of like different pixel formats, image size. Yeah, this is like okay. Won't explain what's going on there. Like some alignment stuff. Upload mipmap. Interesting. So also like texture get names texture from the collection. If it just use one from a cache if we can find one, and then try to load file from collection. And if we were able to get the file, then texture load, file, output texture, and temp memory. Temp memory is needed for, yeah, for unpacking stuff. This project was targeting the Raspberry Pi, which doesn't support DXT textures, and I had to use like a 16-bit RGB 565 texture format, and I had to unpack DXT there. Raspberry Pi can use supports like ETC textures, I believe, and at some point I also wanted to make a really small ETC packer here. Yeah, writing VTF stuff actually, like what the yeah. This association is obvious. Yeah, so texture load, it tries to read the VTF format like header and some. Okay, so I do support only DXT textures here. I actually haven't, I don't believe I've seen anything besides like DXT. So, not implemented, not in texture. Yeah, so yeah, there's nothing besides those ones. And then we jump with cursor to the end of the header and try to get the texture format, like texture image size, texture size, allocate the memory for it, and read the 0 mipmap, like the biggest image there. I don't know why I'm not loading other mipmaps here. I do generate mipmaps in render by calling the OpenGL generate mipmaps function. Probably it was easier than just trying to load the mipmaps here. I'm not sure about quality, which one is the best. Like, they're not guaranteed to be the same actually, because by using OpenGL generate mipmap function, I generate mipmaps from the unpacked DXT, which is a lossy format, and it is likely that WTF mipmaps are generated from the unpacked lossless, like texture before packing, which should be better, but in my case, like, I do have other issues with textures which like worse than like mipmap quality. Like, this is a really minor thing here. So what it does here, allocate another temp memory for the and DXT format. And there's DXT unpacker, which I believe is buggy. CSRC, DXT, C. Like, there's what I was trying to do here, I don't know. Like, this is crap. Color sum, weighted color sum, and DXT. Okay, minimum size, and then go with 4x4 blocks. And yeah, basically, for some reason, I think like DXT1 is the same as DXT5, like, but with some minor differences. Like, it has another offset, and backed is, I'm not sure. I actually forgot like DXT, how DXT works. Okay, let's see. Like this in an overview. It's 64 bits, 2 colors, and 4x4 2-bit lookup table. Okay, and which is and final colors are calculated using this or this. So DXT5 has alpha data, which I don't use for anything. maybe that's one of the reasons why some textures are like crappy. But yeah, there's let me show you actually. 10. Okay, let's open 9. No, not 9. 10. Yeah. A. Okay, let's go here. Like, yeah, this texture obviously needs alpha, which I don't load because this is like this semi-transparent. I forgot the English word for this object. But there aren't any obvious texture glitches here. Like, this color is wrong, and these are like this. Okay, this is not it, but here this is some weird light map glitch. I also don't know why is that. Okay, another level. Let me try. Okay. Yeah, this thing here doesn't look like anything right. This is wait. Do we have anything here? This looks like something that could have like alpha data, but yeah, obviously broken too. Anyway, no, I do want to remove that. So this is another thing that I will need to do at some point. Texture, cache collection, DXT file map, material render, texture C. These are definitions for the VTF texture format, and VBSP is definition for the BSP file format. Okay, so displacement. They do have like this data here, which is like, I don't know the exact semantics of it and what it does. Like, this is something related to like tying several patches of displacement geometry together, and I just completely avoid doing it, and it looks mostly fine. Like, this is like fix me 90 bytes of fix me stuff that I don't care about. And interesting enough, like this stuff is from the wiki page and from other resources like source engine, public sources, and it doesn't add up to 90 bytes, and I'm sure that this is the right value, because that gets me the right result. Okay. So I believe this is pretty much the entire thing. Like there's nothing to show anymore here. Yeah, maybe like I was compiling it with this crappy shell script, which I don't like compile. Okay, let's do it like this time compile. Like 3 seconds, that's a lot of seconds. I think the first thing that I will do today, and probably the last, will be I will be doing a makefile. It's time. And for this I will be reusing I think makefile from here was fine. Yeah, this one, I think I will just copy this one, so I don't like writing makefiles from scratch because like they are mostly like write only. No, that's not what I wanted to say. Like there's a lot of stuff to remember, and I write makefiles like a couple of times per year, and I forgot all about them in the meantime. What does this script do? Like there's some functionality like cross-compile to Raspberry Pi, debug build, what? Yeah, so there's a Raspberry Pi build, Raspberry Pi cross build, or like building on the Raspberry Pi for the Raspberry Pi. Address sanitizer and errors for warnings. Like address sanitizer is mostly like useless for this thing because I don't have any allocations, and my custom like stack-based allocator is like SN doesn't know anything about it. So anyway, this stuff I don't need. Liba sound I don't need. This is needed for some things. Some POSIX stuff doesn't get declared without it. I don't have any C++ stuff in here, so this also goes away. Obscure is fine. No C++. No C++. Okay, this is crap. Actually, no, I don't need this at this point. And this is, yeah, this is intro related, which isn't, I'm not doing anything. Okay, debug tool, run tool, tool. Okay, let's do it like this. And this one, these I need, these I don't need. I do have this stuff here. Okay. Was tab or spaces tabs? Okay. Depths. Tool depths. Tool. Intro is not there. Run tool. And yeah, so this is actually let me take it from here. This is like that and like that for now. Will it work like this? I think it should. So let's try it. Yeah, so this has this copy. Okay, why do I need this here? Whatever. Let's do it like this. So yeah, this is much better. So yeah, make clean, make J10 time. You okay? You will run it, and I don't need that. So open source. Okay, make clean. And yeah, half a second. Which is better. This I like. And then I can do like just like make J10 and it will just open something. Some map here. Yeah, this is cool. I like this. At some point I will need to make the Raspberry Pi build here also. But not right now because I don't have a Raspberry Pi board at hand. Okay. Can I do it like this? Okay, I can probably do it like this and then say like... Okay, I forgot... how do I edit the file? Like just my... just like this, like... okay. So, let's see. Let's see, like, one important thing that I want to do with this project is to be able to load many maps and position them relative to each other as like to have this large seamless map. And for this I will need to read properties from 12 data. So let's look at that. Entity, yeah, so it has this format, which is like this curly brace and then strings in, how this is called, quotation marks. VMF files. Class name, so class name is optional, and then property, and this can be nested. Okay. And then there was, let me consult this thing that I had here previously. BSP, maybe that was it. NTG. Read next entity, class name, info landmark. So this is the thing that I want. So the idea there, let me try to find it actually here. Info landmark. Point entity available landmark for transition to another level. Should be a corresponding info landmark entity in the next map. Entities will be relative to the info landmark. So the idea here with the landmarks is that you have like do they have an example here? Okay, let me go here again. Oh, so this is a class name. So I'm looking for a class like info landmark, which has target name, origin, which is coordinates, and there's another class name, trigger change level, which references the landmark by its target name, I believe, and the map name. Okay. Let me check things. Some I think is nothing. Thank you for the follow. I didn't notice that 18 minutes ago. Sorry about that. So the basically this is this looks really simple. Okay, tablet. Here I go. Here I come. So we have some level of some like weird shape, and at the end of there's like change level. I believe it is a volume. Like if player enters it, it triggers a change level event, and it has another entity which is a landmark, which has a name and coordinates. And this change level, do I remember? Yeah, trigger change level references this landmark by name, because like at some point, at some another point of the level, it may also have like this change level trigger and some other landmark, because like it may reference several levels, and at some point like it references level and it references landmark. So there's this next level. Can I like choose another color here? Whatever. So there's this level which like goes further somewhere, and it also has landmark with the same name, and we can reposition level and merge them here by positioning their landmarks together, because their local coordinates will be different. Like this level may have like coordinates start at this point, and this may have like something weird like at this point. And we just need to move them relative to each other so their landmarks match. So this is the basic idea. So in order to do this thing, I need several things. So let me go to open source, like the entry point here. And there's some, I will need to split this file to like camera goes to a separate file and stuff like that. So there was global stuff for the, actually let me, not maybe BSP by BSP. So this one loads a so-called world spawn. I don't remember what it is exactly. I think this is a chunk of geometry that can be considered as like continuous level. Maybe I load some extraneous things. Anyway, so it loads a BSP model. BSP model is level geometry. It has a bounding box, light map textures, buffers, and draws. So I will need to have multiple BSP models. So for each level, I need to have a BSP model. And I also need to reference so, and each level may reference several other levels. So I need an array of BSP models, named BSP models, because when I load a level, I get several other levels from loading one level. Like when I load a level, it references several other levels, and I need to add them to some kind of a queue, and then pick those levels from a queue and reposition them based on their landmarks. So apart from the BSP model, I need to have landmarks levels. Okay, I'm obviously not doing this today. It's becoming too late. So let me just make plans here today. Like next week we will be doing this. We will be loading multiple Half-Life 2 maps and merging them together, and this will be cool. And probably we will try to load some levels from other games, but I'm not sure about that. Like from Portal or something, but they won't necessarily merge together that well because they're not really continuous. Like elevators do spoil everything. Okay, so this is the first thing. I will need to come up with a data structure to have multiple levels and have a queue of levels to load and some stuff to load them in order, and like to have enough metadata to position them in the right way. Another thing that I will need to do is to parse these this file format, which I think this looks really close to material format, but not quite. So this stuff has quotes and this stuff doesn't have them. Well, I obviously can come up with something that just like, yeah, can eat both of those. And I do have material parser that I'm like happy with. Let me go here. So I will need to move this stuff into a separate file to use from material, both from material and from the entity loader. And yeah, so basically I do have all the pieces for it to almost ready. And yeah, next time we'll be loading many levels and we'll be looking at what Half-Life 2 entire geometry looks like. In the meantime, if you're really interested, you can load the old version of this tool here. Like the main branch here is the old one, like 5 years ago. But it can load Half-Life 2 levels, as you can see here, but it doesn't load any textures, and it has a lot of issues with it doesn't load texture and it doesn't load displacements, so some levels look unrecognizable. And the code base that I'm working on right now loads displacement almost correctly. So yeah, we'll be loading this next week, and it will look interesting. Anyway, this is it for today. I hope it was like... Thank you for watching. Chat was quiet today. Что-то в чатике прям никакой активности сегодня почти не было. And like, as I said before, next stream will be next Thursday. I think I have a stable schedule now. Every Thursday there will be a stream about that thing, and yeah. Thank you for watching. Thank you for like sparse comments, and see you next week. Thanks. Bye.